Okay, so in this video, what I want to show you is a slightly different way of making your robot steer toward the light. Whereas instead of it making just dramatic left and right turns, what we're going to do is if one sensor, for example, the right sensor or left sensor is higher or lower, it's going to hit the wheel and slow one wheel down progressively. So every time it says, whoa, I'm no longer aligned, it slows it down a little bit. If it does it again, it slows it down even more. Repetitively, it slows it more and more and more and more until eventually it comes to a stop. All right. But as soon as the sensors equalize again, in other words, the difference is no longer within that threshold, it resets it to the standard forward value, and then it moves forward until, once again, one of the other sensors becomes outside the threshold, and it slowly begins to subtract or add a value to one wheel to make it slow down, and then slowly turn a robot. So you end up with a more fluid motion. So if it's off just a little bit, it just nudges it. If it's off a lot, it'll begin to turn it more rapidly until it finds the light. Um, so the code for that is, once again, it's going to be here. Okay, and I call that a slightly cooler version. And when I copy and paste it, I have it over here. It's almost identical. The only changes are I had to add another set of variables, which are going to account for that change in speed. I think all this remains the same. Oh, I need to set those variables to a default so that I don't get some erroneous sort of rush when it first triggers in. So I do that in the setup, so that way I have my right and my left set to some default. You'll see that this remains pretty much the same. Okay, all this, the forward, the stop, and reverse. There is a change here. The left slow, I have two arguments now instead of one. I still have the delay for how long I want it to go on. And then in this particular case, I do have a variable here which gets substituted in for the right servo that I'll be changing, as well as, for example, in this one, I have a variable for the left servo, which I'm going to be changing. I added one more change to the check sensors. Last time I was playing with the robot, I realized it was stopping kind of erratically from time to time. I'm going to change that even right there, right now. And I discovered it was because I get some spurious signals from time to time where I would accidentally see something in excess of 500, which wasn't real. So I decided this is such a fast process. There's no reason why you can't average. So you see what I've done right here is I take a value for the sharp sensor, an initial value, and then I take it 4 more times and I average it out and divide it by 5. So that way I get an average of 5 readings before I make a decision on it, which helps eliminate those spurious electrical signals that sometimes pop into your path. The loop, very much similar, okay? I have my let's slowly spin, okay, until we see the light, in which case, because I have that additional argument, I set this wheel to a stop, and then the other wheel is spinning at 1620 in my case, which kind of slowly rotates it. And then, of course, when the sensor actually sees a light, it then moves into this routine here. And this is where we have a little bit of a change. If the difference is greater than 70, okay, the difference between the two values, if it exceeds a certain value, in this case I've chosen 70, you can change that for whatever you feel works best for you. It then compares to see whether or not the left or the right is the greatest value. And then what it does is it slowly takes and adds, for example, 5. Every single time this condition is true, it adds 5 to the value, which is pulsing the right wheel. I do set something, I don't want to go into full reverse and lose the light, so I've set it a stop here, which says, well, hey, let's not go any further than 1480. I don't want to go any further than that. That's slow enough, okay? And it locks it in at 1480. The same sort of thing happens here on the other wheel, okay? And it will then, in this case, subtract 5 from it every single time that condition is true. I have said let's not go any different than 1540. All right. And in the case of this not being true at all right, so the value difference is false. It ignores both of these, all these statements here, and it jumps down to the else statement. The else statement resets those values to the default forward speed, and then we go forward for 30 milliseconds before I check again, and the process repeats. All right, so let me pause it and load it up and show you what it does. Okay, so hopefully we'll get a more fluid steering than we did in the last time. So you can see that it kind of continuously operates. I'll do that again. I also do that stopping and jerking. I'll send it off in this direction here first. And there you go. So let's put this all together in one piece of code so we can do both the RC and the autonomous behavior. So I'll see you in just a few minutes.